Hello, Keith Rucker here at VintageMachinery.org. Guys, today, if you see here on the table, we have received a big order of cast iron straight edges that came in from Windy Hill Foundry. If you follow my channel regularly, you know that over the years I have had some of these made up and been selling some from here and there to people to use as a scraping project, learn how to scraping, and have a tool that you can use when you get through with scraping on your projects. And a tool that is commonly used in scraping is a straight edge. It is basically a reference surface that you can take to a machine for scraping. You take this to your surface plate, you scrape the straight edge in flat to your surface plate. You can then take this to the machine and blue it up, rub it up, whatever, and have a smaller, more portable, basically surface plate that you can use to blue things up on your machinery or whatever when you're scraping in. These are extremely helpful when doing parts on a machine that you can't take to the surface plate, or if you got a dovetail that's kind of down in an area that's kind of below the surface or above the surface of the surface plate can get to, you can get these down into them, and they're very handy tools. They made these in all kinds of different lengths back when they were being made. There's not really any of the major companies still making them, I don't believe. There's some other small guys like me that are making them, but unless you can find the old ones, you pretty much don't have many choices for new ones. I designed some of these. I say design them. It is my design, but it's based on the designs that have been around for a long time. The camelback design, as they often call this, where you have the supporting across the back to support your bottom part, which is your straight edge. These have been cast in gray iron at Windy Hill Foundry. Gray iron is the preferred cast iron material for a straight edge. I know a lot of people say ductile iron is more durable, but from a stability standpoint and remaining flat, actually gray iron is a little bit better than ductile iron in that department. So these are made from gray iron. They were cast. They actually went through a heat treat process to take stress relieving out of them. They are still fairly new castings, and with any cast iron straight edge, it's probably going to move small amounts over time as stresses come out of them. But through the heat treat process, I have found these to be pretty darn stable. I haven't really had any major problems with them. But I always, before I go do an important scraping job, I always take these over to the surface plate, check them on the surface plate, tune them up a little bit if necessary. Usually if they do move, it's just a small amount, and just a little bit of scraping, you can have it really tuned, dialed back in really nice and where you want it to be at for scraping. Anyway, I've got these straight edges. These are, I believe everyone on this table is spoken for right now. However, the foundry is actively casting these and kind of getting me back into stock. I've still got a few in back order that I've got to get people as they come off. But if you're interested in one of these straight edges, by all means, you can get a hold of me at my email down here below, and we can talk about pricing and so forth like that. I don't want to say the pricing in the video because these videos last forever, and 10 years from now, someone will say, well, you said in your video it was that price, and yeah, that was the price 10 years ago. So I'm not avoiding it. I'm purposely leaving that out because, you know, inflation's a real thing. It happens. Prices will go up over time. Anyway, I've got a scraping class that I'm going to be doing here in my shop in a couple of weeks. I've got 10 students that are planning on coming in. This is going to be a 3-day scraping class. This is not one of the Richard King scraping classes like I've done in the past. This is actually one that I'm going to teach myself, and we're going to teach hand scraping. Hand scraping only, no power scraping, just using a hand scraping tool. And the project will be to scrape in a straight edge. And at the end of the class, the students in the class will get to take a straight edge home with them. That will be their project that they get to keep as a result of the class. It's going to be a 3-day class, like I said, hand scraping. We will scrape in straight edges. I've encouraged students to bring along a little project. If they get done with the straight edge early, they can go work on something else and practice their scraping techniques. And I'll be going around coaching and helping people learn the scraping stuff. The class that I've got coming up in a couple of weeks, it's full, guys. And I know I didn't advertise it on the video, but I had a bunch of people kind of that had told me they were interested. They were on a waiting list, and I contacted them first. I've probably got about another 30 names of people that are interested in taking the class that are on my waiting list, and probably the next time I do a class, which I'm probably looking at doing one again before the end of the year if everything goes well, and I'm going to contact the people on my waiting list first before I really start advertising it, just because I don't want to be overburdened with people wanting to take the class and not be able to sign up. If you're interested in taking the class, again, shoot me an email. I can put you on the list. Again, we can talk about pricing and stuff because it's probably not going to stay the same forever. So we can do that over email if you're interested in the class, and I can put you on the waiting list. And basically the way I do this is when I get ready to have a class, I will send out an email to the people on my waiting list, and the first, however many slots we have in the class that respond, they want to take the class and are commit, I put them down, and then we close the class out until we do the next one. If there's interest, I'm going to start doing these classes fairly regular now that I've kind of got my inventory coming on straight edges. This is something I've been wanting to do for a while now, just haven't been able to because we haven't been able to get the straight edges, at least in the quantity that I need to do the class. Now Clark over at Windy Hill Foundry has made some upgrades to his foundry operation. They're able to pour a lot more iron a lot more easily than they have been in the past, and we are finally getting to the point where I've got inventory and more on the way. So that's good news, and I plan on using these again in the classes. So again, if you're interested in a straight edge, send me an email. If you're interested in getting on the waiting list for a scraping class, send me an email. Today, what I'm going to be doing is I've got to get 10 of these straight edges machined for the class. Now, normally when I sell a straight edge, I sell a raw casting. It's up to you to machine it. It's up to you to scrape it. But for the class, just because everybody's coming in, I'm going to be machining a batch of straight edges that we will use in the class. And the machining of that is going to be included in the price of the class when you take it. So, but I'm going to show you the process that I use to machine these straight edges to get them ready for scraping. And that's what we're going to be doing today. So let's go over to the horizontal milling machine and see if we can get going. That's what I tend to use. You can do it on a vertical mill. I use my horizontal mill. It's just a little bit more rigid. I can take heavier, beefier cuts, and I can get these done a lot faster there than I can on my vertical mill because I just have to take lighter cuts on it. But you can get it done either way. Let's go over there and get to work and machine some straight edges. So I'm over here at my horizontal mill machine. I have a Kearney Trekker Model 3H horizontal mill. This is a nice, pretty good sized mill, a little bit bigger than the more common 2H size. It's one size above that, both in the footprint of the table as well as the horsepower. So it's a good beefy machine. I really like these horizontal mills for really being able to hog material off in a hurry. They're just more rigid, more stable, they got more power, and they can really move some metal in a hurry. So these were designed for doing production work, and I guess today, you could call this a production job because we got 10 of these we got to get done. So it's going to be the perfect tool for the machine. I like using the horizontal mill rather than the vertical mill for this, again, because it is beefier and I can do the heavier cuts, but it also is a little bit easier on the setup. The first step in machining these is I need to machine the bottom of this flat. And one thing when I'm machining these straight edges, guys, I tell people all the time, don't be afraid to take some metal off of these. You want to get some metal off of them. A lot of people are like, I just want to barely clean it up. Well, the outside skin of any casting tends to be extremely hard, and when you start going to scrape that, it will be very frustrating. If you can kind of get that outer shell off and get up underneath it, you're in some good soft cast iron. It makes scraping a lot easier, and you're just going to have a better product in the end. So don't be afraid to hog some material off. I'm actually cutting probably about 150 thousandths of an inch off of this bottom, depending on where you are. This is because of the draft angle on this casting. It's thicker here in the center than it is at the top. At the top, I'm probably taking about 100 thousandths off. Down here at the center part, it's probably about 150 thousandths. Rough numbers. But again, you get some metal off. These are designed thick enough to get that metal off of there, get it off. If you're doing this on a vertical mill, typically what I'll do is I'll just put this in my vise, kind of set it straight up and down, and you can use an end mill. I tend to use a face mill to kind of go back and forth and just work your way down. When on a vertical mill, I mean, typically I can only take, 20, 25 thousandths at a time. You tend to get some chatter, the parts kind of moving around a little bit. It's just not as rigid of a setup. Over here on the horizontal mill, what I'm going to do is we're just going to lay this right down flat on its back, kind of like such. And I'm going to clamp it straight down to the table here. And that makes for an extremely rigid setup. And then I can actually do this entire, that 150 thousandths in one pass and done. No playing around, we're just gonna get it done. So that's kind of what my game plan is. Let me get these bolted down. I just typically will come in here and get on one of these ribs. I pull that up tight against the back of the mill, kind of along the ledge of the table there. And we'll just strap it down and let it cut. Hopefully you can kind of see that. It's just chugging right along and cutting that metal right off of there. I'm gonna let it cut all the way across. This machine's trimmed in pretty good, but you'll see a little bit of a crosshatch when it's done. So even when the front cutter gets through cutting, I'll let it cut all the way until this back cutter gets through as well, just to make sure we got a nice clean cut. And we'll let it roll on through. All right, we'll go ahead now and unbolt this one from the table. And nice finish on the bottom. Looks good anyway. Now we're going to pull our table back over. I want to cut them in the same direction. Basically, I want these to cut where the main cutting is going down, so the pressure of the cut is going into the table, not on the other side where it would be picking it up off the table. And again, we'll put our next one in here, get it clamped down, and we'll be ready for number 2. I'm just going to pull that up tight, snug them both up, and then tighten them both up. And here we go. Let her eat. All right, guys, I'll bring you back in a little bit. We're going to go ahead and get all these bottoms done, and then we'll start working on our next surface. So I got all the bottoms of these finished up and milled flat, and my next step here is I want to get this back edge machined square and just cleaned up. This is not a surface that's even being used as a reference surface once the straight edge is done, but it just cleans things up and makes it a lot easier to use. So plus it helps me to have a machine surface to register against and keep the width, the face of the width, all the same in the next step. So to do this, I have made a little fixture here to go up onto the mill. It's nothing fancy. I just made it out of some wood. I just needed something to kind of register that dovetail edge up against in the back here, and that we can clamp it down to and be able to mill across the front here. I'm not trying to take a whole lot of metal off that back piece, just enough to clean it up. Got the cutter going the same speed it was a while ago for the last cut, which is what, 276. I did speed up my feed rate considerably for this operation, making a much lighter cut. We're going 10 inches per minute, and it's having no problem with it. I posted a little clip on Facebook of me milling the bottoms, and I got a lot of people said, "Hey, you're feeding way too slow for cast iron." Guys, I've played around with my feed rate, and because of the width and the depth of cut I was taking and all that, you know, I just kind of went to something that sounded good and then backed off a little bit just because I wanted to preserve my cutters. And I think we were doing 4.5 inches per minute. So it wasn't that big of a deal, but yeah, a lot of people said I should have been going a lot faster, and a lot of people are probably going to say I need to be going a lot faster than this. I'm not in a hurry, guys. I'm trying to get this done, and I'm trying to preserve my carbide too. So there's only 10 or 12 of these to do, so it's not like it's a huge production job. Also, at that little bit slower feed rate, I got a really nice finish on the bottom of this. And this finish on the back is a little bit rougher, but it's not going to matter because we're really not using it. So I sped it up on this operation, but no big deal. I don't know if you can see that or not, but nice surface finish. I'm gonna take a file and just kind of hit this edge just to kind of get that little roughness off of it, but we'll get the next one up here. Well, I got my back pieces milled now. I went ahead and just did all of them, and I know a lot of you guys are gonna probably have something to say about me doing this on a wooden block like this. This was really kind of an experiment on my part to just kind of, I'm trying to figure out my work holding process here, and this was just something I could throw together real quick and easy. Yes, wood is not ideal for machining on, but for this particular job here, I basically was just needing to get that front edge indexed, clamped straight down on this piece of wood, and it held up just fine. We were making a fairly light cut going across that back piece. The cutting pressures were pretty much going down on the part. It worked just fine. However, this is not what I want as a permanent solution to this issue that I got, or this problem, whatever you want to call it. I know that I'm going to be doing more of these straight edges in the future, so I wanted to go ahead and make a more permanent fixture now that I've kind of tried this out. And yes, it did what I wanted it to do. It worked pretty well, and I'm going to be able to use it for 2 operations, I think, in this process. So what I've got here is a piece of steel. This is just some 3/4 inch thick plating. I've got a piece that's 24 inches long, 5 inches wide. I'm going to bolt it down. Actually, I think I want to do is dress the front edge while I've got this cutter set up here, a face mill set up to do it. So I'll have a nice clean front edge that I can line up on the front of my table, and that'll kind of give me my squareness. And then I'm going to mill a little notch, probably about 1/4 inch deep. It doesn't have to be real deep, just something to register up against in here, and then this will all mount down to the table. I can drill and tap some holes in here for some studs that will be in a little bit better position than these here, which are over the T slots. I had a little bit longer. I was clamping more on the back than the front, but I was restricted by where my T-slot is in relation to where my work is. With this, I can put my holes where I need them to be, get a little bit better clamping. So this is going to be a better solution. And yeah, this served its purpose, which was just to kind of test my theory. But now I'm going to move toward this. And like I said, I'm going to probably be doing this machining on these straight edges a little bit more often going forward. So having a jig or fixture here to hold these things permanently, I think it's going to be the option, better route to go. So I'm going to get this set up on here. We'll clean off the front edge there. Then I'm going to bring along my universal head where we can mill straight up and down, and also mill that 45 on the straight edges. So I'm going to get this taken down and this mounted on here. I'm going to have to drill a couple of holes that line up with the slot here, but first I'm going to get that front edge, and then I will get those holes drilled where we can clamp it down. Anyway, you'll kind of see, you'll follow along. Let's get it done. Let that finish cutting across the other side of that cutter, and we'll have that operation done. I've got the universal head mounted over here now where I can basically mill at a 90-degree angle, or pretty much any angle I want to. This is completely adjustable, but I've got it set on just a 90-degree angle right now. I want to mill a notch in here about 2 inches from the back. This is a 2-inch cutter, so pretty much a full width of the cutter, and about 1/4 of an inch deep, and just cut a slot all the way down there. Now, because I got a smaller diameter here and I'm cutting in steel, I got my speed sped up considerably. I think I'm about, what am I on? 466 RPM, but there is a ratio between the gears in here. I don't remember exactly what it is. I'm running a little bit faster than that, but we're still below the maximum range according to the book. So for this type of cutter on this type of material, so I'm just going to raise this up until we touch off right there. All right, I'm touched off. I need to go 250 thousandths on my depth. I want to do this all in one pass, I believe. So let me go ahead and crank this in. And let's see what happens. Cutter's not tight in there and it's sucking down. That's not good. All right. All right, we're going to take another stab at this. I got my cutter tightened up like it's supposed to be, and I did slow my speed down just a little bit. I'm going to slow my feed rate down a little bit. I may try to play around with it. I've got about 125 thousandths depth of cut, which is about half of what I want. And we're going to make a run down through here and see what it does now. Moving kind of slow, but that's where I want to start. Much better. That is cutting effortlessly. To the point that I think we could probably speed our feed rate up. I'm going to go to 2 5/8. This is in inches per minute. I'm at 3 1/8 or 3 3/8 inches per minute. Now I'm at 4 1/2 inches per minute. And I'm just going to let it run right there. We got a little oil on the surface that's burning off, but it is generating some heat. But we were hogging some metal off too, so that's not surprising. All right, we'll just let it cut across. All right, I just went to 5 7/8 on my feed, so I sped it up a little bit. And I think we're just going to leave it right there. Cutting very nice cut. That end's going to probably be down a little bit lower where we had that boo-boo at before, but it kind of is what it is. It's not going to hurt anything. Not going to be pretty, but not going to hurt anything either. All right, we'll let this cut across, and I think we'll have our slot milled and be ready for our next step. So I made one more little modification here. I took these off and I drilled and tapped some 1/2-inch holes in here. These are going to be for some studs for clamping down hold downs. But I think we're ready to try this out. So what I'm going to do is we've got 2 operations to do to the straight edge, kind of in this position. One is to mill the top of this, and the other is to mill the face down here. So with this little fixture that I've got, I can put this up against this back here that will make sure every time I do one of these, I will be indexing in the same place right there. And again, like we talked about before, I've got a good surface area up underneath here. I'm not sitting on this ledge kind of teeter-tottering. I got a lot more surface there. And with these clamps in here, hold downs in here, I can position my clamps and get them where I have proper leverage rather than, you know, my hold down being up here, my T-slot being way back here, and just having really my clamping pressure on the wrong side. So this kind of fixes several things kind of all at once. And like I said, it's been a kind of a process here of going through and figuring this out as we go. So I'm going to put in a block back here. We're going to use these clamps here that have the little pin on the end, and that will allow me to come in here and clamp down on the inside of these holes so that I'm not having to clamp all the way up high up top and that being the way of my cutter coming across. So anyway, we can put those in there like such, and I just got some bolts here. And the reason there's multiple sets of holes in there is I've got straight edges in 3 different lengths, and I positioned the holes where I could share some holes between some setups and what have you, but basically have holes in the proper location for each of the different straight edges that I'm going to be doing, because they're all, the holes in the straight edge are in different positions on them. So anyway, we got options. We can use this with multiple straight edges. So let me get these tightened up, make sure that's up against the fence there. So now I'm going to go through here and we're going to deck the tops of these. I will note, guys, that on this cast iron, this outside edge and these thinner profiles tend to get kind of hard. There's going to be some real hard surfaces in there, so I'm going to probably be making light passes and slow feed rates. Yes, it's cast iron, but I know from experience this top part is going to be hard. So we need to kind of take that into consideration when we're cutting this out. This is not a functional surface from the standpoint of using the straight edge, but I do need a machine surface up here, because when we surface grind the bottoms, this is going to be chucked down to the mag plate on the magnet on the surface grinder with some supports and stuff around it, but this will be the kind of reference surface that we'll use when we grind the bottom. So I do need a flat surface there. All right, let's mill these out. Just increase my feed rate. I'm up to 7 5/8 inches per minute. Seems to be cutting pretty good. I'm gonna go to 10. All right, that's 10 inches per minute. And I can see we're not quite cleaned up again, so I'm gonna have to make another pass. That looks like it's cleaned up all the way across. All right, I got to do each one of these straight edges, the same operation. I'm not going to make you guys watch all this, but we're going to get her done. I'll take that come completely off. I'll swap them out. We'll be back. So we are ready to start working on the dovetail edge. And I did have to make some changes to the setup here to make this work. First off, I had to raise the pallet up just because I just couldn't get it up high enough. With this cutter being tilted out, compared to straight down, the table just wouldn't come up high enough to come in contact with it. I also had to change the cutter because, again, 2 things. With it turned out, I needed that little bit of extra length. But more importantly than that, the other cutter was shorter, and when you were engaging the dovetail, the top of the straight edge was going to hit this post right here and get in the way. So couldn't have that. So luckily I had a cutter that just had a longer extension on it, so I went with that. I also had to move it back on the table a little bit. I had it before where it was kind of right up on the front edge. Like in this mode, it was, when I had it up on the front edge, I had the table moved all the way to the back, and I mean, it would barely do it, but I had no room for adjustment coming towards me. So I just moved the whole setup back since I was going to have to jack it up anyway. So I made those changes. Everything else is pretty much kind of the same here. Make sure that's up against that back. I just set this in here, set it up against the back corner here. We'll snug these down just like before. I made some adjustments to the height and stuff from the last cut, so I'm going to reset off, touch everything off here. I'm just going to bring in, I'll feed in until I just start touching off there. Come back out. I'm going to feed in. I'll feed in about 120 thousandths. And we'll let her cut. Cutting, well, my RPM on the machine is set at 355. The actual RPM of the spindle's a little bit faster. I don't remember the ratio with the gearing in here. We're going to say around 400 RPM. And my speed rate right now is 10 inches per minute. And that seems to be doing just fine. I don't want to get too aggressive with the cut just because of work holding and whatever. I don't want to rip it loose, anything like that. So anyway, this is working good. We'll just let it cut right across. And here are the milled out straight edges. These again are mostly for my scraping class. There's a few other ones mixed in here. Normally I don't machine these when I sell them. You get a raw casting when you get a straight edge casting from me, and the milling is part of your project. But for the scraping class, this is a scraping class, not a machining class, so I'm having to kind of get these done ahead of time. The reason one of them is black, that one's mine. I went ahead and painted it before I machined it. It just looks a little bit, it's easier to paint if you just paint it and then machine off the surfaces you're going to machine. Not to say you can't paint it after the fact, but I didn't know what color people wanted to paint them, so I just painted mine, and the rest of them, that'll be their job when they're later on. But these are all machined. Milled. We still need, like I had mentioned before, I'm going to take these to the surface grinder, and we will surface grind the surfaces, mainly the bottom and the dovetail face. We'll also touch the top because it's going to be sitting on that for part of the grinding process. But other than that, we're pretty much through with these. So I'm going to be getting these ground in time for the class. One other thing that I will do before we grind them, and it's going to probably be about a week before I can grind them, just because I'm about to have to go out of town, and it's going to be a while before I can get back in here and do these. But just letting them sit for a little while is going to help. You know, even though these have been through a heat treat process for stress relief, there's still stress in these castings. And like I mentioned before, removing some of the faces is going to relieve some stress. They're going to move a little bit. So letting them sit for about a week before we go to the grinder should let some of the stresses come out. The other thing that I'm going to do before we grind them, and really before I even let them sit, is I will take each one of these straight edges and hang it up from the end, and I will take like a lead hammer, a soft hammer, and I'm just going to bang on them. I'm going to hit them. I'm going to hit them hard, again, with a soft blow hammer, not where I'm going to be dinging them up, but that's what they call ringing your straight edge. And when you ring it, that's also going to, if there's any stresses in there, that will help relieve those stresses before you actually get in there into your scraping. In fact, when I took the Richard King's great scraping class, he even had us ring the straight edges between scraping rounds, particularly when we were first starting, just to get any last little bit of stresses out of this. They didn't move a lot, but you could definitely tell a little bit of difference when you wrung them between those rough scrapings in the early stage. Now, as you get closer and closer to the finish, you don't want to do that because you don't want it to move very far, but anything we do to get those stresses out is going to be good. And with that, guys, that's going to be a wrap on this video. I may try to do something on the grinding. I don't know. We may try to come back and do a little video on that once we get ready to do that, but I did want to kind of show you this process. I don't really like doing production work, and this is borderline production work. But it is nice that you can set your machines up and just kind of roll through these processes. Normally, it's like I'll do something and then, okay, now I got to tear down for the next step. It is a little bit nice sometimes to set up a machine and get it running good and get it tuned up good, and then roll through your parts, and then you know, go do the next step. But yeah, I don't like the repetition of production work. Never have. I like the job shop work. I like having a new challenge every time I come into the shop and not making the same part over and over again. But yeah, depending on what kind of work you're doing in the shop, you may do some production work. There's nothing wrong with it. You can make good money doing production work. It's just not, for me personally, enjoyable. Guys, with that, that's a wrap. As always, thanks for watching. Please do subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Please hit that bell icon up there to get notifications when new videos are posted. As always, a big, huge thank you to those who support the site financially through Patreon, PayPal, and YouTube memberships. All those are really good ways to help support the site, give a little bit extra, and really kind of enable me to take the time to shoot these videos and do everything that goes along with the videoing part of this. The non-shop work part of it, which takes a lot of time. And with that, guys, we're going to sign off. We'll get out of here. We'll catch you on the next video. Again, as always, thanks for watching.